Welcome. Today we will discuss about MAF sensor, and in this video I'll answer few questions such as what is MAF sensor, how does it work, why do we need MAF sensor, what are the symptoms of bad MAF sensor. Now the full form of MAF sensor is mass airflow sensor. As the name itself suggests, we are measuring the amount of air in the intake system of an engine. And now the question arises, why we are measuring the amount of air, right? For that we need to understand how an engine functions. If we take an internal combustion engine, for a combustion to happen we need three basic things. First fuel, next air, and the spark for igniting air fuel mixture. And there is a condition called perfect combustion. In the perfect combustion, the air and fuel combust and produces the byproducts, and we get the maximum energy out of this combustion. And for that combustion there is a thing called stoichiometric ratio. That means the hydrocarbons and the oxygen in the air combust together and form a byproduct such as carbon dioxide, carbon monoxide in such a way that no fuel is left behind after combustion. That is, we are getting maximum amount of energy out of this combustion. And this stoichiometric ratio is different for different fuels. For example, petrol has a stoichiometric ratio of 14.7:1. That means 14.7 parts of oxygen and 1 part of petrol combined together will form a perfect combustion. And this stoichiometric ratio is different for diesel, it is different for LPG, it is different for CNG. Give me 2 seconds, I'll bring my whiteboard with the block diagrams, which will be easier for the explanation.
A few inches later.
This is a block diagram, and I'll use this block diagram to explain MAF sensor in detail. First we will look at the intake system. Intake system is this part of the engine. In the first part we have atmospheric air which is entering the air filter. Air filter is used to remove all the impurities, unwanted things from the air and supply the pure air to the engine. And after the air filter we have MAF sensor. And after MAF sensor we have engine block. That is, I have taken 3-cylinder engine for the example, and in this we have fuel injector, and after this part is the exhaust system. And in the exhaust system you can find out there is one more sensor. It is called O2 sensor, oxygen sensor, and this oxygen sensor is connected to engine control unit. And even the MAF sensor is connected to ECU, and fuel injectors are also connected to ECU. Now we understood the MAF sensor is measuring the amount of air that is entering in the intake system, right? And after the combustion we will get combust gases, and those gases will consist of carbon dioxide, carbon monoxide, nitrogen oxide, nitrogen dioxide, such gases. And among that we will find trace amount of oxygen as well. That oxygen is found because it is unburned during the combustion cycle, okay? And this O2 sensor is used to measure the amount of unburnt oxygen in the exhaust gases. By measuring the amount of unburnt oxygen, we will find AFR ratio, and this data is supplied to ECU. ECU will decide whether the AFR ratio is rich or lean, that is, air fuel mixture is there, right? In that, whether the amount of fuel is more than the required stoichiometric or whether it is lesser than the required stoichiometric, that is determined by ECU. If we consider rich mixture, it is nothing but the amount of fuel is more than the stoichiometric ratio, and in the lean mixture is opposite of the rich, that is, the oxygen content is more than the required amount. This activity, as you can see from the MAF sensor, engine, oxygen sensor, ECU, this is a cycle and this is called a closed system. This O2 sensor is giving a feedback to ECU, and ECU in turn understands this feedback and adjusts the amount of fuel required for the combustion. So this becomes a closed system. If the mixture is lean, it will increase the amount of fuel injected to the engine, and if the mixture is rich, it will reduce the amount of fuel that is being injected into engine. Okay, and see in the MAF sensor there are 3 wires coming out. First one is power, that is 12 volts power supply, and second one is reference ground. Then the third wire is signal output. This signal output will be in the range of 0 to 5 volts. For some manufacturer it can be from 1 volt to 5 volts. It depends on the sensor manufacturer. In this graph you can see the x-axis is voltage output from the MAF, and on the y-axis there is airflow. As the airflow is increasing to the engine, the voltage output is also increasing. That is, airflow and the voltage output are directly proportional to each other. And when the airflow is very low, that means when it is idling, the voltage generated from the MAF sensor will be around 0 voltage. It can be 0.5 volts or 1 volt. And when it is at the maximum airflow, that means when you have pressed the accelerator pedal to full, that will be around 5 volts. And usually the MAF sensor output will be in the form of PWM signals, that is pulse width modulated signals. When we have pressed very low accelerator and the engine is at low RPM, the amount of air entering will be low and the output PWM will be low. That means the number of cycles, high-low cycles, will be less in a fixed duration of time compared to when it is in a higher RPM and accelerator pedal is pressed more compared to initial. We will find more number of cycles, high-low cycles. In the same period of time we can observe more number of pulses. Now let us understand what are the symptoms of the bad MAF sensor. First point is MIL or CEL. MIL is malfunction indication lamp, CEL is check engine light. This is a warning that is produced by ECU and it is displayed in the dashboard of the car. And next is engine stall. Since we are not getting proper amount of air information, the AFR ratio cannot be determined by the ECU. That means ECU cannot determine whether the engine is running rich or it is lean. That is why we can observe engine stalling issue, we can observe rough idling, and we can even observe erratic acceleration. Now we will understand what are the reasons for the failure of MAF sensor. First one is dust, oil, soot. These impurities may deposit over the MAF sensor's sensing part over the period of time, thus reducing the ability of the MAF sensor to understand the amount of air that is entering the system. Second one is wiring harness damage. This could be because of multiple reasons, because of heat or a mice bite or exposure to corrosion over time. Because of this wiring damage, ECU might not receive any input signal from the MAF, or it might receive intermittent signals or faulty signals as well. This clogged air filter or a damaged air filter will allow the impurities to pass through and deposit over MAF sensor. Next, you might know this fact that the aftermarket air filters or reusable air filter, they come with the lubricating oil that needs to be applied on the air filter. More amount of that oil is applied and that might deposit over the MAF sensor. I want to add one more point. The amount of air that is entering the intake system is dependent on many external factors such as temperature, density, altitude. Cold temperature, the density of the air will be higher, so amount of air that is entering will also be higher. Now imagine we are at a higher altitude place, usually the temperatures will be lower, thus the higher density of air is present, but the amount of oxygen present in that air might differ. Now if you want to understand MAF sensor, we have few tools through which you can understand the parameters of MAF sensor. First one is the multimeter. We can measure the output voltage of the MAF at different RPMs or different accelerator inputs and see the MAF sensor output. And we can even use oscilloscope. This will clearly give you a waveform like this or a PWM output. You can see the variation of PWM in the oscilloscope. And the third one is OBD2 scanner will give you the real-time MAF sensor output voltage, and that output you can compare it with the RPM reading and also the accelerator input. Those data will also be present in the OBD2 scanner. I hope you understood my explanation. If you found out it was difficult, or if you have any doubts, or if I have made any mistakes, please let me know in the comments or DM me in the Instagram. I'll be happy to help you out. And thank you for watching. If you found this video informative, please like, subscribe. I'll meet you in the next video. Bye bye.